In this video, we will going to take up how to uh, animate, how to analyze the knife edge follower on the analysis of cam, how to construct the cam profile and by radial method. So the problem reads as a knife edge follower lift is 50 mm, having a base circle radius is 50 mm, outstroke with simple harmonic motion for 60-degree cam rotation, and well for 45-degree cam rotation, return stroke with the simple harmonic motion for 90-degree cam rotation, and well for the remaining period. So construct the cam profile. Assume cam and follower thickness is 15 mm and it is radial. So first we will going to consider with a radial option. So first, before that, I need to start with the displacement diagram. For the displacement diagram, what is the type of motion we have? It is a simple harmonic motion. So here, the total angle of degrees of rotation for one rotation is 360 degree, out of which it has been classified as the outstroke, then the dwell period, and the return stroke, and again we have the dwell remaining period. So that means if you have a 60-degree cam rotation from the starting point to the outstroke, that is from 0 to the lift of 50 mm, that is from the base circle radius of 50, then it will going to have a lift of 50 mm. That is will going to happen in the outstroke. It happens in 60-degree cam rotation. And after that, at 50 mm radius, that is 50 mm left, you will have a dwell period. That means during that period, there is no displacement of the left, displacement of the follower. So you're going to have 45-degree cam rotation. And then the cam descends in the return stroke with a simple harmonic motion for 90 degree. That means it comes to the base circle radius of 50 mm. And then the remaining period will going to remain the same. So this is the nature of the follower, how it will going to follows the cam. So we need to give the analysis and we need to give the demonstration how it will going to be done. So to do that, so first I need to create some of the parts. Some of the parts which we have is part number one is the housing. Then in the second case, we're going to have a key. Then the third one will going to be the cam plate. Then you have the fourth one will going to be the follower, that is the flat knife edge follower. And the last one which will going to be the shaft. So then after doing that, then we need to assemble that and then we have to say the rotation, then we need to animate the joints. So the first point, so first we're going to consider the housing, how to create this housing. So to do that, first I will go for the uh, fusion, then I will go for the design type is the hybrid, then I'll go for a sketch, click on this front plane. Now we will going to construct the displacement diagram first. So to do that, so first I will go for a line, then I will go for a construction line. The construction line will not be considered for the model. So what I want is I want to generate this cam profile, which is the one which I require in the beginning. So to do that, so I need to have the displacement diagram. This is the profile what I want to construct. So first I will go for the cam profile. So first I need to create the displacement diagram. So to do that, first I will consider a construction line of any length. Then I will go for dimension. Then give the dimension as 50. So once you do that, now we will have a line from here. I will draw one horizontal line of any length. Then I will go for dimension. I want 360 degrees. So 1 degree is equal to 1 mm. So that is the scale which I am considering. And here 1 mm is equal to, that is the 50 mm what we are considering. Then from here, I will going to draw one vertical line of any length. Then since you have the outstroke for 60 degrees, from here I will draw one line. Then I will have a 45-degree well. I will consider 45-degree well. Then I will have 90-degree from somewhere here. So that. So now we have all the four. So then I need to go for constraint, select equal, select between this and this. So again, you select between this and this, and you select between this and this, and then you select between this and this. So then I will go for line, select this endpoint and draw a horizontal line. Now I need to adjust the angle. So do that. We'll go for dimension between these two. So I go for dimension between, go for dimension between these two. I will take this as 60 degrees. So 1 degree is equal to 1 mm. So 60 degrees is equal to 60 mm. That is the scale. Then again, from here, I will go for dimension. I will go for constraints. Remove that constraint. Then go to dimension between these two. So this will be 45 degree. That is the dwell period. And again, from here to here, it is 90. Go for 90 degrees. And the rest will going to be 165. So that you're going to get, it will be 360 degrees. So now this will be 165. Okay. Once you do that, now I want to divide this 50 mm lift into 6 equal segments. So to do that, I will go for circle, select the midpoint of this line and draw one circle of radius 25. Then again, I will go for create. I will go for circular pattern. Select this vertical line and go to select on the center point. And then you go for partial, give the angle as 180 degrees and you give 7. So that you will go to have 6 mm, divide the circle into 6 segments, 1, 2, 3, 4, 5 and 6 and say OK. Then you go for trim, select this and you trim this portion. Okay. So once you do that, so the trimming is over and again I will go for trim on this side. Now the next thing is I want to have the displacement. So I need to divide this into 6 equal segments. So to do that, I will go for rectangular pattern. So I will select this particular object. Then I want to go for spacing. Then the quantity what I want is, I want to divide this also into 6 segments. Go to 6 segments. And then the distance between this is 10 mm between these two. So you have 1, 2, 3, 4, 5 and 6 and say the quantity in the other direction is 1 and say OK. So this is one thing. Similarly, I want to go for create, go to rectangular pattern, select this and again give the distance as 6 and here the distance is 15 mm because it is 90 there and here it is 1 and say OK. Now we have both the outstroke and that is outward stroke and the return stroke. I have divided. Now I need to get the line. I will go for line, select this endpoint to this perpendicular. Okay. Similarly, I will go for line, select this and draw perpendicular to this and then press escape. Similarly, I will go for line, select this endpoint and draw perpendicular to this. Okay. Or midpoint, whichever. It will take automatically. Again, you go for line, take endpoint to this perpendicular. Similarly, I will go for line, select this endpoint and then this perpendicular. Okay. So once you do that, now we have the entire the displacement diagram. Now I want to join all these points by means of a smooth curve. So I will disable these points. Okay. Then again go for a fit spline. remove the construction, and now we want to create the actual curve. Take endpoint to this intersection, to this intersection, to this intersection, to this intersection, and to this endpoint. Okay. Then again, I want it from this side. So you go for fit point spline. So take endpoint of this to 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 endpoint of this and press enter key. Now we have all the lines have been completed. Then I will go for trim. Select this trim and you trim this portion. Similarly, you trim this portion, this, and you trim this portion. Then you go for select, remove this line. Similarly, remove all these lines. It is not required. Similarly, you do it on the other side also. So to do that, again, I will go for trim, select this portion, this, 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 and this. Okay. So we have the displacement diagram completed. Now, the next thing is I want to construct the camp plate now. How to do that? So to do that, first we will go for the reference of this line. So first I need to draw a circle of radius 50 mm. So that is the base circle. So I want to do that. So I will go for a circle, select some arbitrary point and go for dimension, give it for 100. Okay. Then you go for coincident, select on this point to this point. Then I will remove these dimensions. So now, then again, I will come down to this, create a circle of diameter 40. The next one, go to circle, select some arbitrary point and go for dimension, take the dimension as 40. Then you go for constraint concentric between this and this. You have that point. Then again create one more circle of radius 12.5, that is 25. Again go for circle, select this and go for dimension. Go to diameter is 25. Again you go for constraint concentric, select between this and this. Okay. Now once you have this, now we will try to move this inside. I will go for move, select this entire thing and press it on this rectangle by holding the first button of the mouse. You bring it nearer so that the accessibility becomes easier for me. And then you say, okay. Now, once you do that, now we have the constraint. Okay. Now we want to draw the displacement diagram. So now this is the profile. Similarly, I want to create this keyway here. So what is that? 5 mm and to a depth of 16. So to do that, I will go for this keyway is on the inside of radius 12.5 circle. So go for rectangle, select some arbitrary point and then draw a rectangle of any size. And now here you go for dimension. You take this dimension as 5. Sorry. Enable dimension. You go to dimension. Sorry. Select this dimension and write it as 5. So go to dimension here. Okay. So here I will just delete this first dimension. Then I will go for dimension, select this and give it as 5. Enter. Now I want to keep this at the center. So I will go for dimension between this point and this center and make it as 2.5. So horizontally I have aligned it. Then go for dimension between this and this center and give that dimension as 16. Okay. Once you do that, now you go for trim this portion and this portion. So now we have this entire profile has been created. Once you do that, now I will going to switch off this dimension, disable that. Now we will create the, so since we have the displacement diagram, what we have the 60 degrees, 45, 90, and the remaining is 165. So now similarly, I want to do it on this side, on the scam plate also. So to do that, again, I will go for line, go to construction, draw one vertical line of any length. Similarly, again, you go for line and draw one line of any angle. Similarly, you go for line and you draw at any angle. Then again, you will draw one more line at any angle like this. Then go for dimension between these two and you give the angle as 60 degrees. Okay. So once you do that, you will enable the dimensions. Again, you go for dimension between these two. You will get 45 degree. Yes. Again, between these two, you take it as 90 degree. Yes. And the remaining period will be 1. Okay. Then you just press escape. Sorry. Go to dimension. Go to 90 degree. Enter. Okay. Okay. Now I will press escape. Once you do that, now I will segregate this so that you will be able to see the entire thing. When you are trying to do your modeling, you will be able to have these dimensions which is required. So I will go for diameter 100, then I will go for diameter 40, then I will go for diameter 25, then you come down to this and you keep 16, and this dimension is 5, and this dimension is 2.5. Yes, 2.5. So these are all the dimensions what I want. Similarly, on the other side, yes, you need to have this displacement. Okay, I will go for pan and I will try to move in. Okay, I will say okay. So this is how you will be able to do the dimensions for the entire profile. So this is the one what I require. Once you do that, okay, now I need to go for the further. So that means actually the vertical position will going to be the 0 degree here, what we are considering. That is at the base circle, the follower will be at this particular point. So from here, the outstroke is 60 degrees. So I want the outstroke of this 60 has to be here. You have 6 segments. So here also I need to have 6 segments. Then from there, 45 degree, that is from once you have the lift of 50, then from there, 45 degree to the same distance or the same displacement. Again, the outward stroke, that is from 100 to, again it comes back. So that is during this period from the 50 to this, from 100 to this 50, you will be having this descent. And then the remaining period will be 360. That is from here to here, you will have the radius. Already the cam profile has been generated between these two. But the remaining 3 portions, I need to do that. So again, I will just go for dimensions and remove the dimensions now. So now I want to divide this segment. So I will go for trim these portions now. Okay. Once you do that, now we go for create, go to circular pattern, select this as the object and center point as this and give the partial. Okay. Then I want to have the angle as 60 degrees. Then the total segments will going to be 7. Now I want to take it onto this side. Okay. So how much angle? 1, 2, 3, 4, 5, 6, and 7. So I want 6 now. Since I want 6, I will give 6 mm, 6 degrees. So each one will going to have 10 degree each. Okay. So between these two should have a trend. So 1, 2, 3, 4, 5, and 6. So I will say okay. Now we will try to show the dimensions. I'll go for dimension and check whether you have that 10 degree or not. It is there. Similarly, arbitrarily, I will going to check one more from here to here. Again, you have 10. Okay. Similarly, I will measure between any two. It's 10. Okay. Now this is fine. So now the outstroke we have divided. Then from here again 45 degree, it is the dwell period. So that means here when you go for theta, you can see this outward has been done. Then from here to here it is 50. There is no, I mean 45 degree. There is no variation in the displacement, that it remains at the same point, at the same radius or at the same lift of 50 mm. And again it should come back. So this has to be divided into again 6 segments, which is that one. So I want to construct by this. So I'll go for fit and I will go for pan and I will take it here and say OK. Now I will go for create, again go for circular pattern, select this and take the center point as this. Then it is partial. Again I want 90 degree here. Then 90 degree divided into 6 segments. Then you hold this and you rotate now. You bring it here. Okay. So you have 75, 50. Okay. 1, 2, 3, 4, 5, and 6. And say, okay, now. Now we see the dimensions between these two. Likewise, I check 15 degree. Yes. Again, I will check between dimension between this line and this outward. So 15. Obviously, now all other slots will be having 15 degree. Yes. So this is how we will be dividing this. So now what we have done, we have divided the segment into 6 equal segments in 60 degrees and also in 90 degrees. Now I need to start with the profile. So to do with the profile, so what I need to do is, so from this point to this point, the displacement what you have here is this dimension I want to take. Say, I'll just explain here. The dimension from here to here is 3.349. Okay. So that distance has to be there here. That means from here, this line should have 3.349 outward. Okay. So to do that, since it is radial, so radial means always it starts from the center. So first I will going to consider a line of any angle. Then I want to align these two now. Go to constraint, go to collinear, click on collinear, select between this and this. So it becomes collinear now. Then I want to go for dimension. Okay, sorry. I will go for dimension. Select this line and give the align dimension. Okay. Okay. Go to dimension, select this. Select this dimension and click on measure now. Which one I want to measure? I want to measure this line. Okay. Select this measure. So this actual measurement is so much of things. You just press enter. So once you do that, now you can see that length has been changed. Similarly, I want to go for one more. I will show you. So before that, I will try to move this displacement so that it will become easy for us to uh, select. So I will go for modify, click on move, select this entire thing, okay, and move it nearer to this so that it becomes easy for us to snap this. Okay, now we will come to this point. Okay, now this becomes easy. Okay. Again, I will go for line. You select some arbitrary point and give some angle. Then you go for dimension. Sorry, go to constraint, go to collinear between this line and this line. And then go to dimension. Take the align dimension here. Click on these three dots here and click on measure. Select this line. So it is 12.5 from the radial. Yes. So now this dimension has become 12.5. If you check, yes, it is there, 12.5. Similarly, again go for line, select this from end point, and you draw one more line of any length and go to dimension, sorry, go to constraint, go to collinear between this and this line and go to align dimension of this. Then click on triple dot here, go to measure, which is the measurement. I want this one now, that is 25, and enter. So now this dimension will become 25 now. Yes, it is there. Similarly, I want to repeat the same thing for all other points. I will again go for line, take this, draw one particular line of any length and go to collinear. Do it one by one. Don't try to do everything at a stretch. That becomes difficult for you to do that. Again, go for dimension, go to measure, select on this line now. So here it becomes 37.5. So you go for dimension, so 37.5. Again, you go for line, select this and draw any dimension of any length. Again, go to constraint, go to collinear between this line and this line. And again, go to dimension, select between this and go to measure, measure this one now and say enter. So you'll check this dimension again. It is 46.651. And if you try to check this also, 46.651. Yes. Similarly, I go for line, draw one line from here. Remember that it should be always a construction line because that will not be considered for your modeling. That is the only for drawing we are considering that. If you have a continuous line, then it becomes very difficult for you to do the extrusion because every sector we need to consider that. So again, you go for constraint, go to collinear, select between this and this. Now you will go for dimension, select between this and go to measure, measure this line and say enter. So this is over. So similarly, at this particular point also, you will have a lift of 50. So now what we have done is we have gone from 0, that is from 50 mm to 100 mm, we have gone there. Now we want to maintain the same thing from here to here. So again, I will go for line, select some arbitrary point and then drag a line here. Then you go to collinear, select between this, select between this and this, and go to dimension, select this, go to measure, click on this line now and press enter. Okay. Now we have the extreme point. Then it start receding now. It has to come down now. Again, I will go for collinear, select between this line and go to dimension between this and click on three dots here, measure, select this line and say enter. Again, you will go for line, select some arbitrary point and then click, go to collinear, select between this and go to dimension, go to measure. First one is over, second one is over. Now you come down to third one, 37.5. Then you will come to this point, drag this, sorry, because that will be taken as vertical. So then it won't be possible for you to align it. Go to collinear, select between these two. Then you go for dimension, select here, go to dimension. I think it is constrained now because I've already given the dimension now. So that is the reason. So here I will delete this Okay. Then go for line, select this line and give collinear, select between this line and this line and go to dimension, click on measure. Measure is what? I want to measure this line now and give 25. Once you do that, then you have this line, take endpoint, okay. Then again go to collinear, select between this line and this line and go to dimension, and go to measure, select this line now, it is 12.5, okay. Then again I want to go for line, select this endpoint, then go to constraint, collinear, select between these two, then you go for dimension, select this line, go to measure, come down to this and click on this side, okay. Then press enter key. So we have all these lines which we have been constructed. Now we go for fit. So we have generated all the points which was there here. I have transferred into these points. Now what next? The next thing is what I need to do is I want to join all these things. How? By using the spline. You just go for spline, remove construction. Now you come down to this point. You take endpoint of this to endpoint of this, sorry. Go to spline, select endpoint of this to endpoint of this to endpoint of this to endpoint to endpoint to endpoint to endpoint. Press enter key. So now we have the outward stroke. Then from here I want to have the same curve. So I'll go for create, go for arc, take the arc, center point of arc, take the center of this, and from this endpoint to this endpoint it will remain the same. Yes. Then after that I want to come down, again go to spline, fit spline, take endpoint to this 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 endpoint. Enter. So now we have the entire cam profile has been created. Now I want to remove the remaining portion here. I will go to just go for trim and I will remove this. And similarly on the other side, I will just go for trim and I will remove this. So we have the cam profile, total cam profile of the one which has been given to us. I will delete this. Okay, this is the actual one. So now I will go for, this is the actual cam profile. I will go for finish sketch and go to 3 dimension. So I will come down, remove this. Sorry, I want to go to this. Now I want this profile, which is 15 mm. Okay. So to do that, I will just go to extrude, select this profile and give the distance symmetric, take on equal side, total distance as 15. Okay. So we have the cam profile, which is the new body, and you just click on OK. Now we have the cam profile, cam plate. Now I will go for sketch, again enable sketch. Now we have the inner portion here. So which is that keyway, what we have this portion, which is for 25 mm. So to do that, I will just go for extrude, select on this, okay. Again come down to symmetric and take the entire length as distance as 25. Okay, since it is joined to the original one, you say okay. So this profile has been generated. Now I will disable the sketch. So now this is the actual cam plate, what we wanted to do it. So the name of this has been cam plate. So I will just go for this. I will go for appearance, So what is the nature of appearance? It is yellow. So I will go for paint, then come down to glossy and take by holding on the first button of the mouse, you drag this onto this model and say close. So now we have generated the cam plate. So once you do that, you just go for save, then you write it as cam plate or cam profile plate, whatever you want, you can call. So this is the first model what we have created. So this is the only one which is going to take much more time because we need to go for creating the displacement diagram and then generate the base profile and transfer all those points onto this cam profile. So that will take much more time. It is just like doing the drafting. So then once you do that, now this is the first part is over. Now we will go back to the next one. We will go for key now. So to do that, I will just go for key, go for sketch, select on this. Okay. Now you go for rectangle, select some arbitrary rectangle of any length. So what is the dimension of this? 5 by 6. So I'll go for dimension between these two. You give 2.5. Then I will go for 5. Then on the other side, it is 6. So you'll just give the dimension for this as 3. Okay. And this entire length as 6. So we have the dimensions such has been done. So once you have this, for better clarity, I will remove constraints so that you will be able to see the dimensions. Okay. I will bring this here or I will take it out. Similarly on this, then I will take it out here and then I will bring this here. So that this is the square rectangle what I want to create. Once you do that, now I will go for finish sketch and then go to 3 dimension. Then what is the thing which I want? I want the thickness, the depth is 25. So you will go for extrude, click on this and take the dimension as 25 and say okay, new body. Then you go for appearance. Then you come down to paint and click on blue and say close. So we have the second sketch. I will go for fit. Okay. Now I'll go for save. Then I will go for key. K-E-Y. Oh. So this is the second part which we have created. Then we want to go for the next one. So I'll just close this, come down to the next part, that is the housing. So to do that, so first I want to create 260 by 220. This is not exactly at the center. So this is 260 and this is 220. And this 260 is from the top, it is 160. Then from this side, you can take 120. You can take 100 at the exactly at the center point. This is what I'm trying to give here. Okay. So this, the dotted one, what I'm showing here, or the circle, what we have here is this one. So this is center point, that is at 100. And this rectangular slot is on this side, which is 92.5 from the one edge, and then 20 mm from the other edge. Let's see, that is at the later stage. So first I want to create a rectangle. I will go for sketch. Okay. Go for sketch, click on the front plane. Now I will draw one rectangle of any length. Okay. Then I will take from this center, it is 160. And this is at 100, correct? So I will take this dimension from here to here. It is 100. Okay. And then this total distance is 220. I will just go for dimension, give 220. Okay. Yes. Then from this, we have 160. I will go for dimension between this and this. you give 160. Okay, then the entire thing is 220 or 260, correct? Yes. Click on this and give it as 260. Okay. So once you get this, now I have a finished sketch and go to 3D. Now we will take that dimension as 15. Okay. You click on this extrude, take 15 here on this side. Okay. Then again I will go for sketch, click on this and go for circle. Select this. And what is the diameter of the circle? Diameter of the circle is 25. Correct? Yes. And go for dimension. Give the dimension as 25. Then go to coincident. Select on this point with reference to this and go for finish sketch. And go to extrude. Select this. And the distance is through all and flip and say OK. Then once you do that, now we will go for sketch. Click on the top plane now. Then go to rectangle. Select from this point and draw one rectangle of any length. Okay, it's 220 only. I will constrain directly from this point. So now we have 60 mm this on this side. So this is 220. So first we will going to do that. I'll go for dimension, select this and give 60 mm, correct? Yes, yes. Give this dimension as 60. Okay. Then go to finish sketch and go to extrude, select this profile and take the distance as minus 15. Okay. Because it's going outside, I mean, the direction is along, it is on the opposite direction. So I want to give minus 15. So basically it wants to join. So I will click on join now. So once you do that, we have this particular point. Now I want to create one square of 15 mm, which is 92.5 from this edge and also 20 mm from this edge. So to do that, I will go for sketch, click on the top profile, and then create one rectangle of any length, of any size. Since it is 15 mm square, so I should have constraint is equal. Like I will take equal, select between this and this. Okay, both becomes equal. Now we will go for dimension. Take this dimension as 15 mm square. So we have constraint on the square. Now I will go for dimension between this and this. Give that dimension as 92.5. So you give this dimension as 92.5. And again, so I want from here to here now. I want this dimension to be 20. Okay, so we have constrained all these things. Once you do that, you go for finish sketch and go to 3D and go to extrude, select this profile and give the distances through all and flip and say OK. So we have the housing. So once you do that housing, so the housing is in green color. So I'll go for appearance and you come down to green and drag it and place it. So I'll go for a close. Now I will go for save, click on housing and type it as housing. So this is the third model what we wanted to create. Okay, once you do that, now we will going to close this. So the next part is the follower. So to do that follower, so we will go for this one. So we since it is a knife edge follower, so we're going to create this knife edge follower now. So first I will go for a line. I'll go for sketch, click on the front plane. Now I'll go for line, select some arbitrary point and you keep it here. And then you drag this on this side. Similarly on the other side, on this side. Of course, you can keep it on one side and constrain it and then mirror it. That also can be done. So first I will go for the center point. See, basically first I want to place it at the center, which is 15. No? So I'll go for dimension between this and this. I will give 7.5 first. Okay. Then I will go 7.5. 7.5. Okay. Then I want on the total distance. So here I want the total distance to be 15. So automatically the other dimension will going to come. Now I want both should be collinear, coincident on this and also on this side. Oh, it's not taking. Okay, we will do the other way. Now we will go for dimension between this line and this line. What is the dimension? The dimension has to be 160. So you give 160. Okay, we got this. Now we want to have this angle 45. Go to line, go to construction, select this and you draw a one line. Now I want to give this angle. So to do that, go for dimension between this and this angle. I want it 45. Okay. Similarly, from this and this line, you will have 45 degree. Okay. So all the things have been constrained now. So once you do that, you will go for finish sketch and go to 3D and go to extrude, select this profile and give the distance as, symmetric and give the distance as 15, both the sides. So once you do that, new body, you create this. Now we have the follower here. Now the follower is made out of red. Okay. Again, you go for appearance, come down to red and click on this and say close it. So now we go for saving this file and go for follower, enter. So the next thing is the last one, which I want to create is a shaft. So the next part is the shaft here. So we have the diameter and then I want to open the keyway slot of 5 mm, which is at the center and which is at a distance of 25 mm. So to do that, I will go for go to sketch, click on this profile and go for circle, select some arbitrary circle. The diameter is 25. So go to dimension and give the diameter as 25. Then go to coincident, select on this and you take it onto this. Okay. Then after that, I want to create a rectangle of 5 mm and it is at a distance of 10 mm from the center. So I will go for rectangle. You select some arbitrary point and then draw this. Okay. Then I will go for dimension. You select this dimension and give it as 5. Then this should be placed at the center. So I'll go for dimension between these two and give the dimension as 2.5. Then I want to place this dimension from here to here it has 10. Okay. So we have this entire thing has been completed. And now I'll go for finish sketch and go to 3D and go to extrude. Okay. You select this and you select this also and give the dimension to be 40 mm first. Give the distance as 40 mm on one side. Okay. Okay. Then you go for sketch, enable this sketch and go to extrude, select this extrusion and give the distance as 25 and then the operation is cut and say okay. So now if you see this, so you have the cutting has been taken place only up to this dimension. Okay. Now I will disable the sketch. So I want to save this. So since it is in the white color, so I will just go for appearance and you come down to white and say close it. Okay. Then I'll go for save, type it as shaft. So now we have created all the parts of the model. Since we have created all the parts of the model, now we have to go for the assembly section. So to go for the assembly, so I will just close this, go to part design and make it hybrid. This is the best method which we will be doing it. So the first thing is I want to call this as a housing. I will drag this and place it. This is the first part which I want to make it as a ground. So basically the first part what you create is automatically considered as a ground and you just click on OK. Then I want this shaft to be placed here. So you just drag this shaft and place it in this. So you take it out and you just close it. Now I go for 3 dimension and you OK. Now you go for joint, select this profile, the center of this with reference to the center of this. So now it has been actually the slider, but I don't want to slide. Instead, the shaft has to rotate. So I will go for motion. So go to revolute and you can see the revolution is taking place. So I'll go for preview. So you can see it is considering the revolution. So I'll go for 3 dimension and I will say preview. So it is start rotating in anti-clockwise direction. Okay, you just click on this and say okay. So the second part has been considered. Now I want the camshaft. Sorry, the cam plate. So I will just drag the cam plate and come down to here. So now it is placed at the exactly at the origin, and so I will just click on OK. Now I want this cam, go to joint, select on this point, on this point to be on this side. Okay. Now I'll go for flip. Okay. Now it has been placed at the point. Now if you see here, so there should be a gap. Yes, it is there. So now I want this to be rigid with the shaft. So I'll go for, because if this has to become revolute, then what happens? Both will going to have the revolution. Then, so my condition is when the shaft rotates, the cam should also rotate. So that means the cam should be mounted, cam plate has to be mounted on the shaft. Okay. So the shaft is rotating with respect to the housing. Housing is fixed. So the cam should be fixed to the shaft. So then only you will going to have the assembly. Otherwise, it is not possible to have the relative motion will not be taking place. So I'll therefore goes to the motion and here you come down to rigid and say okay. So once you have this, now we go for the next part, which is a key. You just bring down that key here and you place it here. So you drag this key and keep it outside. Now I want that key here, which is joint. Select on this surface, that is on this point. So take the cursor on this face and bring, by holding the shift key, you bring the snap point on the corner. You just click on this and go to fit. Now you come down to this point and here you click on this face and by holding the shift key, take to that corner here. You can bring it here and you click. So now the shaft has been placed, key has been placed at this point. Now you just go to flip and you flip it. So now it goes exactly into this. Again, since it is on the motion is to be rigid, you just go to motion and click rigid. So now everything is coupled now. So now you can see everything has been seen. Okay. So now the both the key, shaft and the cam plate are all fixed. So then if you see this, if I go to 3D, now I will go to the relationship and go to joint. If I revolute, see what happens. I will just go to animate joint relationship. Now if you see that here, all the both the shaft, key and the cam plate is only rotating. Whereas the housing is still in this the same position. So this is what we are expecting. So this is how it should be assembled. So once you do that, I will just come out of this and go to 3D. Now I will go for a follower to be placed. So now I will just drag this and take it outside. Click on OK. Now I will take the joint, select on the top surface of this, okay, to the top surface of this, okay. So now it has been fixed. It is rigid. Previously it has been considered rigid. So now I want to make it slider. So now it is actually sliding. So then I will go to front. Now it is exactly placed at this middle of this. That is, the tip is placed at the middle. Okay. Now I want that distance. If you go for the preview motion, you can see that the follower is sliding along the Z axis, and I will just click on this. So it is at the center. Okay. Now we will say OK to this, or you just go to rest. Okay. I will type 50 now. Once you type 50, now you can see that placed at the above the base circle or the tip of the base circle. Then you have the tip of the follower is resting. So I will just play OK. Now you go for this. So once you want to revolute, see what happens. Animate joint relationship. So what is happening is, so we have individually, we are being able to move it. Now suppose if you go for the slider and if you slide, so you can slide along this direction. So everything has been done, but only thing is I need to establish a contact between these two now. So to do that, I will just go for assembly, enable contact sets. Then you can see the contact sets is been established here. Now I will just go to contact set, right click on new contact set and take this cam plate and this follower and establish a contact. Now you can see the moment when you do that, automatically this point is contacted at the base circle radius. So automatically it will takes to that particular point. So once we have established this contact, now if I try to rotate, see how it is moving out. So this is how this will be able to generate it. Now what I will do, I will just go to revolute. So now I will just go to revolute and click on animate joint relationship. Now it is start moving it in, coming out. So if you try to explain this, so at this point you have 0, then again it starts lift, continues, come down, lift, continue, come down, lift, and it comes down to this part. This is how we can be able to say that the outward stroke, dwell, return stroke, dwell. Outward stroke, dwell, return stroke, dwell. Outward stroke, return, outward, dwell, return, dwell. Outward, dwell, return, like that. So this is how we will be able to establish the relationship between the cam and the follower, which is having a lift of 50 mm from the base circle of the cam profile. So this is how we will be able to demonstrate that the problem what it was given here, the 45 consider the cam profile having the thickness by radially. So we will be able to establish this particular uh, animation of this cam profile with the follower with the knife edge. Thank you.